Hey everyone, Mr. Newman here. We're just going to do a practice for the 2.1 quiz on functions. So first of all, this functions, I have to say whether a graph or a table is a function and whether it's discrete or continuous. Remember that a function or something is a function if it has only one output for each input. And something is discrete or continuous, well, discrete means that there are separate parts, and continuous is that they're all connected. These are the ideas. One way to check with your pencil is if you can draw it all without picking up your pencil, then it is continuous. If you must pick up your pencil to draw the different parts, it is discrete. So let's get started on part A. On a graph, we want to use the vertical line test to see how many outputs there are for every input. Every vertical line you could possibly draw on this graph only hits 1 point, so it passes the vertical line test, which means it is a function. This is also continuous because, as you saw there, I can draw the entire graph without picking up my pencil. On the next table, notice if 1 is the input, 4 is the output, and for the second line, 1 is the input and 5 is the output, that is a problem already. You can't have two different outputs for the same input. So that is not a function. And we can stop right there. As far as discrete or continuous, because they are separate points, those are not connected, so that is discrete. They are separate points that you would have to draw by picking up your pencil. For the next graph, I can start with the vertical line test, and all it takes is one bad point or one bad pair of points, and you know right away it doesn't pass the vertical line test, so it is not a function. Also, these are separate points, so it is discrete. Moving on, we now have the points laid out in a different way. Notice that -1 is the input and 9 is the output, so I'm checking all the inputs, and I see that there are two that are the same. That doesn't mean it's automatically not a function. We need to look at the outputs, and lo and behold, 4 and -3 are different outputs, so we have two of the same input with different outputs. That is not a function. Also, these are separate points, so it is discrete. For the mapping diagram here, you have to read this. Notice that 1 goes to 5 and 2 goes to 5. Well, that is actually not a problem. You can have different inputs go to the same output. Beware of that, especially on the table or the points. If you have lots of different inputs, they can go to the same output. That is not a problem. You can write a rule for that. But if you have the same input go to different outputs, that is the problem. So those two arrows I marked in red there, 1 goes to 4 and the input of 1 goes to the output of 5. That is a problem, so this is not a function. Also, these are separate points. They're not connected, so it is discrete. For the functions here, I give you the function f of x equals -x plus 2, and the input is -4, so we're just going to plug -4 in. But this is where you have to be very careful how you write it. I'm going to write these one at a time. So notice I wrote -x plus 2, but instead of x, I put the parentheses. The parentheses are very important here, because if I don't write them, I could easily mess up. Let me put the -4 on the inside now, and do you see now where you might mess up? A lot of people don't write both negatives. They think they covered it by just writing one negative, but the opposite of a negative, in other words, the negative of a negative, is actually a positive. So this is 4 plus 2, which is 6. If you flip out and on the quiz or test you forget about the opposite of a negative or the negative of a negative, you can actually type that first line right into your graphing calculator and it will tell you what that value is. Now I'm just doing a little dashed line to differentiate between A and B. Here, 7x squared, I'm writing 7x squared from over there on the left, but instead of x, I'm going to put parentheses. Once again, I write the input is -3, so I'll put a -3 inside there. And here I need to follow my order of operations, GMDOS. Remember that exponents come before multiplication, so I need to do -3 squared before I do 7 times anything. That gives me -3 squared is -3 times -3, which is 9, and 7 times 9 is 63. Once again, if you flip out, you can always put this right here directly into the calculator, and you'll get 63. Thank you for watching.